We are demonstrating a generic infrastructure management and cloud initialization framework for ORAN, supervised by Professor Chien-Chao Tseng from National Yangming Chiaotong University, presented by student Yifan Li. The demonstration consists of two parts. First, we will showcase FOCOM-enabled cloud and IMS initialization automation. We have deployed the SMO platform with the following components: our FOCOM implementation, AWX for enabling cloud and IMS initialization automation, and open source Mano, which serves as the NFO. In this demo, we will automatically convert a cloud infrastructure based on the Proxmox hypervisor into an cloud. We will request FOCOM to start an Ansible playbook workflow on AWX. This workflow will create VMs, set up a Kubernetes cluster, deploy IMS on the target infrastructure, and convert it into an cloud. In the FOCOM web UI, we begin by adding an cloud entry. Next, we perform the cloud and IMS initialization with FOCOM, provide the Ansible inventory for the target infrastructure, and then provide the workflow definition. FOCOM will trigger AWX to start workflow. In the AWX UI, you can see that the Ansible workflow has started. Now the cloud is successfully initialized. On the target infrastructure, you can see the VMs for the cloud Kubernetes cluster are created. Returning to the FOCOM UI, the status of the cloud is now available. After IMS registration, FOCOM collects information about the cloud and registers the new DMS of Kubernetes with NFO or open source Mano. In open source Mano, you can see the newly registered DMS. Now let's deploy network functions to the cluster. We will deploy free 5GC and OAI-CU DU to the cloud cluster. First, we deploy free 5GC. Then we deploy OAI network functions. The deployment is now complete. In the cloud Kubernetes cluster, you can see all network functions are successfully deployed. Next, we will demo the O2 closed-loop control for the node shutdown energy-saving use case. We have set up a Kubernetes cluster with 4 worker nodes in the cloud and deployed the energy-saving app in the SMO. The IMS will collect metrics from the cluster nodes and submit them to SMO FOCOM, where the metrics are provided to the energy-saving app. To simulate changes in cluster load, we will create and delete network functions on the cluster. The energy-saving app will control the power status of worker nodes through O2 IMS based on the cluster's load level. Initially, only one worker node is active. As we start deploying workloads on the cluster, you'll notice the memory usage increasing. When the memory usage surpasses the threshold, the energy-saving app requests the cloud IMS to activate an additional worker node. So the average memory usage rate decreased. At this point, the third worker node is powered on, followed by the fourth. Then we begin reducing the number of workloads. You can observe the memory usage decreasing. As a result, the app starts turning off nodes. Ultimately, 3 worker nodes are powered off.